Rubix Talent Kids.
Hi friends, my name is Nidhish. Today I will be explaining you the topic force and pressure. This topic will come for you in 8th grade. Now let's learn about force and pressure. Friends, now let's see what is a force. So what is force? A push or pull which tends to change the state of motion or rest of a body. Force is denoted with the letter F. Friends, force. We can define force as a push or pull which tends to change the state of a body, state of motion or a rest of a body. Friends, for example, let's take a ball. It's going in this direction. Now if you kick it, it would go in some other direction like this or stop. This means that if you are kicking the ball, it means that you are pushing it. So here the ball is in motion and you are pushing the ball, then the ball will come to rest. This is an example. This is what is force. Here the push, we kick the ball. It was okay. Let's take this ball. We kicked it and it is going in this direction. First it was in rest. You kicked it and it went in this direction. This means that you are applying force on the ball to change its state of rest to motion. This is called force. Now let's go on to our next topic. Types of force. So friends, there are two types of force. Contact force and non-contact force. What is contact force? For example, let's take a ball. Now you kicked it. Now it is going in this direction. Here the force from your leg is applied on the ball and the ball started moving. Here the ball and your leg were in contact. Your leg was touching the ball. So the leg and the ball were in contact. So that this kind of force is called contact force. So let's take some nails. So here are some nails. Now you take a magnet. Now you take a magnet near to them. The nails get attracted to the magnet. Here there is no contact between the magnet and the nails. This kind of force is called non-contact force. This kind of force is called non-contact force. Now let's see some examples of contact force and non-contact force. Friends, now let's see the types of contact force. So the first type of contact force is muscular force. So what is muscular force? What is muscular force? The force exerted by the muscles of a human or an animal. For example, let's take your running. Your legs are exerting force onto the ground. That is a type of muscular force. You are daily going to school. You are lifting your bag. Your muscles are exerting force. That is a type of muscular force. Animals, a cow is plowing the field. Now the cow is exerting force. Now these are some examples of muscular force. Now let's see the next type of contact force. So friends, what is frictional force? This is the next type of contact force, which is, we can define frictional force as the force which opposes the motion of a body is called frictional force. For example, let's take a ball and you kick the ball. Now the ball is rolling on the ground. Now the frictional force stops the ball. As you all might have noticed that the ball gradually stops after rolling for some time. This stops due to frictional force. Now let's see the types of non-contact force. Friends, now let's see the types of non-contact force. The first one is magnetic force. Now you take a magnet, you have a pile of nails, you have a pile of iron nails. Now if you take the magnet close to these nails will get attracted to the magnet. There is no contact between the magnet and the nails. This is a type of non-contact force. This type of magnetic force can happen between the opposite poles of magnets, like the north pole of a magnet and the south pole of a magnet. These two get attracted. Now here we take the north pole of a magnet, here we take a magnet, we take another magnet. Now we keep the south side and the south side close to each other. They both repel, but if you keep the opposite side, they attract. This is also magnetic force. Now let's see the next type of force. Friends, now let's see the next kind of force, which is gravitational force. We can define gravitational force as force of attraction between two large bodies of mass. Here you can take the example as the earth and the moon. Earth, if you throw an item into the air, it would gradually fall down. This is due to gravitational force. Here, the earth attracts the items. Now you throw a ball in the air. The ball is in the air and this is the ground. The ball comes and falls down after some time due to gravitational force. The earth is pulling down the ball. This kind of force is called gravitational force. Now let's go on to our next topic. Friends, now let's see the next topic, which is units of force. First, let's learn about the units of force. SI unit of force. SI unit of force is Newton. It is denoted with the letter capital N. Here SI unit means the unit which we use are all around the world. Now let's see the next kind of unit, which is gram force and kilogram force. The gram force means take a item which weighs up to 1 gram, hold it in your hand. The force that the bag applies on your hand is known as gram force. Now the similar happens to the kilogram force. Instead of taking a object weighing a gram, you take an object weighing a kilogram. These two are another two units of force. Here we can convert kilogram force into newtons. 1 kilogram force equals to 9.8 Newton. We can approximately take it as 10 Newton. Now this is the conversion. Now let's see our next topic. Friends, now let's learn about resultant force. Now in many kinds of areas, you may see that many forces act on a body at once. Like you play the game of tug of war. Here there are some players. So here, from this side, there is some force applied on the rope, and from this side, there is also some force applied on the rope. Here, resultant force means the sum of all the forces. Sum of all forces is called resultant force. Now here, there are some different situations where the sum of the forces also change. Now let's see those cases. The first case, which is the force of the boats acting in the same direction. Now here, these people are trying to pull the rope from here to this side. The both are acting on the same side, then we add those two. Now one from this side they are pulling it to this side, and this side they are pulling it to this side. Then we subtract, and these are the two types where the resultant force must be added and subtracted. Now let's see some cases. Now here, from this side they are applying a force of 200 Newton, and this side they are applying about 180 Newton. They both are acting in the opposite directions. Then we have to subtract them. Then we will have 200 Newton minus 180 Newton. Then we would get 20 Newton. On the up of the number you should keep the direction of which side the force would act. Now 220 Newton to this side. Now let's see another case. Now you and your friends are pushing a box. Now this is your friend and this is you. You both are pushing a box. Now you both are applying. Now your friend is applying a force of 50 Newton and you are applying a force of 80 Newton. Now you both are applying the force in the same direction. Then you add the both forces. Then you would get 80 Newton plus 50 Newton, which equals to 130 Newton. Now let's see our next topic. So friends, now let's see our next topic, which is balanced and unbalanced force. Friends, now let's see our next topic, which is balanced and unbalanced force. Now let's see about balanced force. We can define balanced force as when the resultant force is 0 Newton, then the force is said to be balanced. Now when the resultant force is not 0, then the force is said to be unbalanced. Now let's see the next topic, which is the effects of force. Friends, now let's see the effects of force. Friends, there are 4 effects of force, which is, the first one is change state of motion or rest. Now a ball moving in this direction. Now you kicked it in this direction slowly. The ball stopped. Here you applied force. The ball stopped. It was in motion and it came to rest. The ball was in rest here. Then you kicked it. It started moving. Then it changed the state of rest to state of motion. Now that is our first effect. Now let's see our second one. Force can change the direction of the body. Now for example, the ball is going from here to here, is moving in this direction. Then you kicked it like this. Then the ball's direction would go like this. Here you applied force on the ball. The ball moved from here to here. This is what the second effect does. Now let's see our next effect. Change size and shape. Now let's take a balloon. Now if we squeeze it, it would become something with any direction when you still apply force. Now the shape of the balloon changed. Now this is one of the effect of force. Now you took a spring, you pulled it, it becomes like this. Now this is an effect of force. Now let's see our next effect. Now the next effect is change speed of a body. Now a ball is moving in this direction. Now you kicked it again in this direction. The ball would move faster. Now this is an effect of force. Now let's see our next topic. Friends, now let's learn about pressure. Here let's take a knife. Now this knife is blunt. Now you are trying to cut an apple. It wouldn't cut properly. Now you have to exert more force. Now this is what is pressure. Now let's take another knife which is very sharp. You try to cut an orange, it would cut easily. Then you have to keep less effort. Now this is sharp, and now the blunt knife has larger area compared to this one. The blunt knife has large area. This side it has some thickness, but this has small area. Smaller. Now it has very less thickness. Now it can cut the orange easily. So here, the smaller the area of contact. So this side it is very small. Now the smaller the area of contact, the more the pressure. Now this is very small. It's very less thick. Now it can slice easily. That means that it has more pressure is exerted than this one. Here the force is more. Here the force is less. Here pressure is more. Here pressure is less. Now let's see the formula for pressure. Pressure is denoted by the letter P. Pressure equals to force by area. Here force is denoted with the letter F and area is denoted with the letter A. Now pressure equals force by area. Now here let's take 100 Newton. You are applying force here. Now let's take this case. You are applying the force of 100 Newton and the area is like 5 meters square. Then the pressure would be 20. The SI unit of pressure is Pascal, which is denoted with the letter PA. Now let's see our next topic. Friends, the SI unit of pressure is Pascal. It can also be written as Newton by meter square. Now here. Now let's learn about pressure by fluids. Now here liquids and gases, both are combinedly called fluids. Now we will learn about the pressure exerted by these two. Now let's see an activity. Here let's take a vessel. Let's make 3 holes at different depths. Now we'll fill it with water. Now from the bottom hole, the water would go till here. From the bottommost hole, the water would come from here to here. From the next above hole, the water would come from here to here. From the topmost hole, the water would fall here. This is due to the pressure exerted by fluids. Now this means that the depth of the container also plays a role in the pressure exerted by fluids. Now let's take another vessel. We will make some holes. Now from this side the water would fall like this. Now the distance from here to here where the water falls and the distance from here to here where the water falls is equal, which means that the pressure exerted by the fluids is equal in all directions. Also here, the size of the container doesn't matter. The depth of the container only matters. Now let's take two containers of different sizes. They both have the same depth. Now we make two holes. The water falls from here to here and here to here, have the same amount of distance. This means that the pressure exerted by fluid doesn't matter in any shape or any size of the container. Let's see Pascal's law. Now take a bag filled with water. Now you make two holes. Now the water would fall off. You squeeze the bag. Then the water from this hole and the water from this hole would fall at the same distance. Not a distance more or not even less. The both would fall at the same distance. This is called Pascal's law. Pascal's law states that pressure applied to a fluid is transmitted equally in all directions. This is Pascal's law. Now let's see the pressure exerted by gases. Friends, now let's see the pressure exerted by gases. Now the pressure exerted by the air at any point on the earth is called atmospheric pressure at that point. Friends, now here the pressure exerted by air at any point on the earth. Now here, let's take somewhere. Now let's take a point at a hill, and now let's take a hill, and here this part. Here you are standing, and here is your friend. Now the pressure at this point is different from this point. The pressure from this point is different from the pressure at this point. This is the meaning of this statement. Now pressure exerted by the air is applied here at the both points. The pressure is exerted by the air, but their height varies. That's why the pressure at the lower point is more and the higher point is less. That is what this statement means. Now let's see our next topic. So friends, here, now let's learn about barometer. What is barometer? So a barometer is a device which is used to measure atmospheric pressure. It was created by Torrison. Now let's see how he made the barometer. So this person took a bowl. He filled a tube and filled it with mercury. Now he kept his thumb on this tube like this and flipped it and kept it in this bowl. Now he kept it like this. The mercury stopped at this level. Now he took a scale. He kept it beside it. Now he measured this full part is filled with mercury and this part is empty. Now we have to measure the distance from here to here. Now this part is the atmospheric pressure. The atmospheric pressure at the ground level is 76 centimeters of mercury column. This is Torricelli's barometers model. Now there are some other scientists who created some other barometers. Now there are some people like 14 and Anna. These two are some people who created different kinds of barometers. This person created a barometer which was fixed to the wall. Now it would show the pressure at any point where the barometer is, and this person made it as like a compass where it would give the direct reading. Now let's see how large is atmospheric pressure. Here let's see how large is atmospheric pressure. Now at a area of 1 centimeter square, the atmospheric pressure would be like 1 kilogram force. Now your hand may be approximately like 100 centimeter square. Then the hand would be experiencing 100 kilogram force, which means that like 2 people of your age, 2 to 3 people of your age would weigh that much, but your hand wouldn't feel it. Now if you keep your hand in the air like this, then you won't feel that much force on your hand, because the force applied on your hand is equal in all directions. Now you kept your hand like this. The atmospheric pressure from all directions is equal in your now this is all atmospheric pressure on your hand. So friends, here you kept your hand like this. The atmospheric pressure from all directions is equal. Now the force from this side, this side, this side, this side, this side, from all sides, it is balanced. That's why you won't feel that much force on your hand. Thank you friends, that's today's video. If you like my videos, please like, share and subscribe. And I hope this video helps you in understanding the lesson force and pressure. Thank you.